Section 4.2 is about logarithmic functions. Say let f of x equal a to the x, where a is greater than a is positive and a cannot be 1. So if it's greater than 1, you get a graph like this. If it's less than 1, you get then the opposite. Okay? So based on that graph, we get that f is 1 to 1. How do you know? Well, it passed the horizontal line. Okay? Since it's 1 to 1, it also has a inverse function. Since that function we just looked at is a exponential function, the inverse function is called the logarithmic function with the base a. So basically, you have f inverse of x where equal y, or f of y equal x. Similarly, log base a of x is equal to y, where a to the y. So the important log base a of x is the exponent when you get a base a to the x. So here's an example. Write log base 2 equal 4 exponent 1. So we just said that a, so let's say this is our base a, being out to the x, that we get our logarithmic function. So 2 to the 4 equals, so another way we write it is log of 16 with the base of 2 is equal to 4. Right, 9 half equal 3. So log base 9 of 3 is equal to, since a to the x and log base 8x are inverses, they cancel out each other. So that is, if you have a log base a with a to the x, so these a's cancel out. Give you x for all x for all in real numbers, and if it's a log base a raised to log base a, this can give you x for all x in 0 to infinity in that range. So this is some of the common expression. Log base 3 of 1 equals 0. So if I was to do 3 to the 0, well, anything to the 0th power is going to be 1. Log base 4 to the 2, so equal 1 half. In here, you have 3 log base of 3 equal 4. Well, these tend to cancel out since you are the same exponent. So you are just with just that number. Similarly, you can cancel these out, give you negative. So we could look at the range and domain. If it's an exponential function, the domain is going to be all real numbers, and the range is going to be 0 to infinity. If it's the logarithmic function, well, it gives away. Your domain of the uh, exponential will become the range and vice versa. So the question is, how do you sketch this graph? Well, one of this easy way, pick, since you have the base 2 over here, choose powers of 2. So you start with 3, x is negative 3. So you get 1 8. Negative 2 to negative 2, you get 1 fourth. To negative 1, 1 half. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the squared is 4. 2 to the is 8. And you just graph it. If you look at it, 0 is 1. This red line is f of x, and the g of x is the inverse, is the exponential function. So our question is, the function g of x is log base 2 of x minus 2 plus 1. The transformation of the function log base 2x. Use this to sketch to graph of g. identify the domain and its range. Well, if it is just log base 2x, then the graph will go from here to this way. We are shifting it 2 units to the left, also 1 unit. The domain is 2 comma infinity, 2 comma infinity. The range is all real numbers. And you have an asymptote of x equal 2 because that's where this becomes 0. It was a common logarithm, so if it's a base, if it's a logarithm with a no base, we assume it's means a base of 10. Similarly, you could also a natural logarithm by ln of x. That just means you have a base of or base with the Euler's number. Simple the point. Natural log of 1 is 0. That's anything to the 0th power will give you 1. These are opposite, they cancel itself out. In here, the natural log of 1 over negative e to the squared. From these cancel it out, you do 1/2, which is the same thing as this e and natural log cancel out, give you x. This natural log and e's cancel, give you x. These are the same thing. And natural log of 7 is approximately this number, and you can only do that by calculating. Asking find the domain of this function. Well, since it's a natural log, it is defined when x is greater than 0. So we solve for where x is greater than 0. Over x, solving it is the square root of both sides. So the x has to be between negative square root of 3 and positive square root of 3. Well, we want when x is positive, so x has to be less than square root of 3. The domain of this function is x, given that the absolute value is less than square root.